Yes, and we are live. Good
Great.
morning.
Good morning, all the folks interested in AI in the Bay Area, West Coast, California. Thanks for joining us for this September edition of Trends in AI. My name is Jakub Savrel, the founder of Zeta Alpha, and co-presenting this show with Dinos.
Hi, everyone. Good afternoon from Amsterdam, and thank you for staying this late on a pretty windy Friday. I'm Dinos, research engineer at Alpha and co-host of the Trends in AI show. Yeah, so this is the September edition, pretty special one because of the topic, which is none other than enterprise RAG. So, for those of you joining the show for the first time, we cover a bit of the trends, recent developments, funding, model releases, and yeah, the special edition is about enterprise RAG. So, we'll go beyond the basics and see kind of what makes it so challenging and what are the opportunities in the future in this field.
So I'm presenting live from San Francisco. Strengthening the Zeta Alpha domination of the world here in, I don't know if you can see behind me, in a very cloudy San Francisco. Yeah, the energy here in the city is just amazing. Here you can see a few pictures of some of the meetups that we have attended in the last week. So, for example, we were at the AI Agent Summit organized by the MLOps community of Demetrius Brinkman. Uh, the picture on the left-hand side of the screen is pretty funny because there was like a huge meetup. There were lines around the block outside, and I think around 2,000 people signed up for that meetup. 2,000 people, and there were about 20 companies, mostly startups, like small startups, bigger startups exhibiting. And in this picture right here is a smallish startup called Anthropic. Uh, and the sign that is on the table here, it says, "Come talk to us about Claude Code." So that was pretty funny, I thought.
I think
We
this is the
went
first.
to
I think this is the first frontier lab that's so aggressive with their marketing.
I know this is the $1 billion marketing budget. Yeah, yesterday I was at the Llama Lounge in Palo Alto, SAP Labs. The AI Collective organized a very nice meetup last week. So yeah, it's very cool to go to all these meetups, meet the startups, meet the researchers, and hear what's going on. Everybody's like totally buzzing about agents. The other show that we went to was Open SearchCon, beginning of this week in San Jose. So Open Search is the core of our search solution, and a great combination of a modern vector database and a more robust, reliable enterprise search backend with all the sort of classical information retrieval and search engine features. So lots of new innovation there. And if you can click further, Fernando had a great talk about LLM as a judge, which of course is the way you evaluate search engines these days. And my highlight of that conference was a very cool talk by one of the engineers from NVIDIA, Corey, who showed how NVIDIA is also looking at vector search for GPU acceleration. And they have some pretty amazing breakthroughs, especially in indexing and using GPUs for indexing. And if you can click one more, HNSW is kind of the norm for vector search, for approximate vector search, and they have launched this new algorithm called Kagura, which achieves very large, like order of magnitude speed ups over HNSW, especially for constructing the graph on GPU. So that was very cool to see, and it's actually available in OpenSearch.
Right, and we were in AI Dev here in Amsterdam a few weeks ago, and I think their trillion vector scale search, I think the underlying breakthrough was this indexing upgrades and speed ups.
Exactly. Yeah. So very exciting times, both in AI agents and in search.
Yeah, so this was all the buzz from San Francisco, but let's kind of broaden the scope now and see what has been happening in AI in terms of the industry and developments. Starting with kind of a controversial report, I would say, from
Yeah. So
MIT.
this is not exactly news. It came out in August. So it's been a few weeks now, but we just wanted to cover it because it keeps kind of coming up in every discussion, and I think the tone is set by this headline from Fortune, where the headline says this MIT report. It's a report which came out from the MIT NANDA research group, which is an AI agents research group, and they kind of surveyed bunch of corporates and organizations which are building AI systems in companies, and they had some pretty bearish findings, right? That not all of these projects were exactly successful. But the headline that made it into the media is that this report concluded empirically that 95% of generative AI pilots at companies are failing. Well, if you read the report, and it's really worth reading, you see that that is not actually what the report says. The report says 95% of AI pilot programs, not things deployed to production, fail to generate a return on that investment for now. So I think it's still very early stages, but that's a very important qualification. So failing is not like didn't actually deliver any sort of meaningful system. It doesn't generate millions of revenue or profit yet. So I think that's an important qualification.
Yeah, and I'm sure no one doubted that it's hard to build these systems. Otherwise, everyone would have had them already, and certainly it's not 5 lines of code to get them to production.
Yeah, and there are many other interesting details in this MIT report. One of them is that obviously sort of the evolution from simple RAG systems to more agentic and more sophisticated systems with guardrails and quality control is a necessary condition for these projects to succeed. Another interesting finding hidden somewhere in page 17 or so of the report is that a lot of companies over the last years have been kind of prototyping their own AI systems, building your own. And this study also finds that these build your own projects are twice as likely to not go to production than AI projects that are built together in a partnership with vendors. So that's of course encouraging for companies like Zeta Alpha.
Yeah, let's save the why for later in this talk. And maybe to contrast this, there was also recently a study in the report out by Google Cloud, who were had a bit more positive spin. So this is kind of their key insights piece, and I would highlight a few of these numbers, starting with saying that about 50% of the organizations that use Gen AI internally also have successfully deployed an agentic AI use case in production. And many of these other pretty high numbers that you see here, so 88% of early agentic AI adopters have seen RI on at least one Gen AI use case. And if you have an eye for detail here, you see at least one Gen AI use case being mentioned in most of these figures. But I would also highlight at the end of this slide here saying that the challenges, the number one by far, is still data privacy and security concerns that are the top consideration that is blocking executives from greenlighting these production use cases.
Yeah, and that's also what you see with a lot of these build your own kind of prototypes, right? I mean, um, just slapping a vector database and a RAG system together is not maybe the road towards really enterprise ready systems, especially when you talk about things like access rights. But we'll go into that in a bit.
Right, so kind of going back to our normal format for this webinar, let's cover a bit of the funding, which is quite overwhelming, I would say, this month.
Yeah, the hype or the successes of collecting huge funding rounds from AI labs and startups at incredible valuations just continuing. I think topping the numbers is Anthropic's recent raise, closely followed by Databricks at both going kind of past the 100 billion valuation. So large investors are just pouring incredible amounts of money into the leaders in this race, but also some quite um, um, recently funded startups like Black Forest Labs and EXA and Bassett and Sierra. Yeah, really collect very large funding rounds. EXA is an interesting one. Have you heard about that one, Dinos?
Yeah, so they have a kind of a search engine kind of trying to beat Google, I guess.
Yeah, so it's like a really end-to-end new entrant in the web search engine space. So they're crawling at scale and having kind of an AI first approach to both crawling and indexing web search. It's rumored that OpenAI is using them in their web search capabilities for ChatGPT. And of course, Perplexity continues to raise slightly smaller amount than you would expect at those valuations. So I don't know if that's because they need the cash to keep sort of fueling their growth rate, or whether it's really going to some significant investments. They offered to buy Chrome for 39 billion, I think. Quite recently, but that didn't go through. Google got to keep it. And one other item on this page that I just wanted to highlight is that rumor has it that there's quite a lot of tension brewing between OpenAI and Microsoft, and it's exemplified by this very recent news that Microsoft is actually also including Anthropic, interestingly, in its lineup of models that it will present to customers. So I think that's a big breakthrough for Anthropic.
Right. I wouldn't say I'm surprised, but definitely shaking up the field a bit. And yeah, I mean, mentioning OpenAI and these big
Mentioning
numbers.
big numbers, so this is a very big number. So research by the Wall Street Journal just uncovered this deal. I don't think it was maybe publicly announced, but the Wall Street Journal published it, and Oracle's stock just went through the roof. So basically, the sort of public information about the deal is that OpenAI has committed to consume $300 billion worth of Oracle's cloud services for AI training and inference. So that's about 60 billion for a 5-year deal. It is rumored. Huge numbers. And in the graph on the left side with research done by the information, you see how this kind of looks in terms of evolution of OpenAI's profitability. And I don't know if it includes this very recently announced Oracle deal, but for sure, most people are thinking that OpenAI won't be profitable anytime soon. So it's huge cash burn. The AI cloud inference and infrastructure game also has a European component. Amsterdam-based Nebius Group reportedly also signed a deal for $17.4 billion with Microsoft. So even though Microsoft is moving to Anthropic and other providers as well, they're also continuing to beef up their own infrastructure for Azure. This is kind of contrasted with some other recent news. The US Bureau of Census Statistics published this interesting graph here, use of AI by business size. And there we actually see in the top green line of the graph, for companies over 250 employees, a slight drop in their use of AI, self-reported. So this is, I think, interview data. But I think that's very interesting kind of counterpoint to all of these huge investments being made in the infrastructure. And then the last one on this set of clippings, we've also seen Salesforce report fairly weak AI revenue very recently, which led to a dent in the Salesforce stock price.
Right, so definitely a lot happening on the investments, but as you said, this is not always, maybe not in reality with the models, how the models are performing. So in this, we're trying to kind of gauge how GPT-5 is doing about 1 month after its release.
OpenAI's flagship model, right? The big breakthrough, reportedly, that we have been waiting for a long time.
Yeah, so obviously numbers are not public, but from what we can tell from OpenRouter, which is kind of a service that people can use to route their requests to multiple models or the best model at the time.
So this is API requests, right? Not like consumer demand.
Exactly, yeah. And what we see here first in coding, programming use cases, and then more generally in their growth in the weekly and monthly trends, it's not really breaking even the top 5 or top 10. And surprisingly, even models like GPT 4.1 mini is doing better, if not a lot better, in terms of both growth and percentage of use cases.
So what could be the reason for that?
Yeah, so my feeling and what I've seen online a lot is that it's a very hard model to wield, and it's very sensitive to prompting. So it's a lot further away than what an upgrade from 4.0 to 4.1 would have been. So people are really not able to use it to its max potential right now.
Yeah, so just upgrading to it seems sometimes to produce unwanted effects, right? Or like kind of hard to keep the behavior you had in your existing kind of systems. The other thing that I see in this leaderboard is Sonoma. What the hell is that?
Yeah, so this probably is a stealth model. We don't know from which provider yet, but it seems to be doing almost as good as Claude and Grok Code in coding, and similarly pretty well, at least better than GPT-5 on normal use cases. So what could this be?
So it's amazing that already such a large volume of tokens is being routed to this stealth model, which nobody really knows what it is. I've heard rumors that it's a new model from Google, actually, that it's might be sort of the Gemini 3 being battle tested in these anonymous benchmarks.
Yeah, I will definitely see soon enough, maybe in the next edition of the webinar. But yeah, let's kind of switch gear a bit and cover our usual appearances of the open releases, because we're all for open space AI. And surprisingly or not, China is still leading the space with kind of the usual suspects by now, I would say. So we have Kimi K2, which is a model that's a very sparse mixture of experts model, which had their update recently last week on a more agentic model that supports also longer context. And yeah, you can see also ByteDance in a lot of modalities. They had their video model recently, and they came forward with the release of an open source language model, pretty competitive and Apache licensed. DeepSeek also had the V3.1 update. It's a bit better, I guess.
A
Just
small
trying to,
update to the
yeah,
existing DeepSeek model. I think what they did is that they merged the DeepSeek V3 line with the R1 line, right? That's kind of the reasoning or mixed mode thinking and non-thinking model of DeepSeek.
Yep, exactly. And yeah, finally on this slide, we have ZAI or GPU as they were formerly called, with GLM 4.5 and 4.5V, which is, if we go back to the previous slide, we can see it's also pretty popular for a bunch of use cases, and definitely
That's
a
a
very good
strong
and capable
multimodal model,
model.
right?
Mhm.
Yeah.
Yeah, but I think the fan favorite in open AI models is Qwen 3, which also had or is having these releases as we speak. So just today they announced Qwen 3 Next, which is kind of a new architectural journey they're taking with sparse MOEs and kind of optimized attention modifications. And also Qwen 3 VL, which is being released as we speak. I think still no announcement yet, but people have found it in Hugging Face mining through the pull requests. But yeah, I think at least personally, this is the model that I would opt for if I would want to have something local and fully offline. It's a really good model.
But QN3 Next is a pretty large model, right?
Yeah, so this one is huge. If I remember correctly, it's like 1 trillion. No, actually, no, this one, Quen 3 is still not that big. So it's 80 billion and 3 billion active.
Okay,
But
so
it's
that you can
the,
actually run that on a single GPU if you have a
yeah,
pretty
yeah,
big
it's
one.
just very sparse, but I think that's their goal. They want it to be still usable, but benefit from this high sparsity efficiency that comes in inference time. Yeah, so you mentioned the Gemini 3, but that's still all kind of
That's
rumored.
still unknown.
But where Google really shined this month and got a lot of public real estate was with Nano Banana, which was a very weird name, which stuck with people. So actually, what this model was 2.5 flash image. And then just days after the release, they said, okay, we're actually keeping the old name that everyone knew it by. And what this model is just image generation and image edit model, which by benchmarks, both internal and public ones like LM Arena, yeah, it seems to be blowing everything out of the water. Have you played with it?
No, I have not, but I've seen sample images popping up all over social media. So both LinkedIn and other social media are flooded with pretty cool images from this model.
Yeah, but also, surprisingly or not, we had another model from Google, which is EmbeddingGemma. And this is obviously they had their commercial line of embedding models, and now they have open sourced one, which is for me a very interesting finding. This is based on embedding on Gemma T5, so it's kind of a throwback architecture for these days. But what they achieved is, I think, quite remarkable here. They have, I think, this is around the size of a BERT or GTE base model, E5 base model, but it performs on the level of the large variants. So for its size, it's performing top of MTEB, even nearing the Quen embedding 600 million model, which is the next level.
Yeah, and so this model is about half the size of that. Well,
Right.
I think the difference is not so large in practical terms, but it's a cool release, absolutely.
Right, and what people are mostly excited about. So this model is natively multilingual. They trained it on a lot of synthetic data on multiple languages. And yeah, it has the usual things we see nowadays with Matryoshka and longer contexts. But I think the main selling feature here is the storage efficiency and the quantization aware training, which lets this model potentially even run on a CPU.
Yeah, that's a big difference, of course. If you are going to index a couple million documents in an enterprise search use case, being able to scale it out on CPU will definitely save you a lot of money.
Okay, so back to European news.
Yeah, so this is in the funding category. I think the web has been buzzing about this. So Mistral was rumored to be doing the rounds for a new series of investments, and what was I think the most surprising part is that the lead investor in this around $2 billion raise is not one of the sort of global sovereign funds or one of the lead big VC firms, but is a large behemoth of the European tech industry, Dutch chip making company ASML. So, what do you make of that, Dinos?
I'm not sure. For me, it's a kind of a big jump between the area of business that ASML is usually in and where Mistral might be used for them.
Yeah, so
But
I
yeah,
think
it seems like a
I,
European play, right?
I think it's very much in the sort of category of European AI sovereignty being solidified, and I think both the French government and the European Union kind of couldn't let it happen that Europe's flagship frontier lab, Mistral, would be snapped up by an American investor or by the Middle East. So I think they really were keen on keeping this in European hands, and I think probably the French CEO of ASML received a phone call at some point from somebody in France. I wouldn't know who it was, but to really help them make this decision. What's also interesting, if you can still go back to Mistral, in the light of our topic that we're going to dive into in a bit, enterprise RAG, is that it seems that Mistral is investing strongly in its capabilities to deal with private data. So in their flagship Le Chat product, they have recently launched, just last week, a way to have the Mistral chatbot take private data from your business applications through MCP, though. And what's interesting is that actually in the list of MCP connectors, I could not find SharePoint, which I'm sure ASML is using. So I don't know if ASML just bought a really expensive enterprise RAG solution, which doesn't have SharePoint yet. Well, I'm sure they'll fix that pretty soon. So yeah, in kind of other European news, this is of course our neighbors from Lab 42, Cusp AI, a very cool European AI startup focused on material science. Basically, the goal of Cusp AI is to build models that are able to synthesize new materials for large problems like carbon capture and the energy transition. And they just managed to raise 100 million in new funding. And the picture is actually in our office in Lab 42, I think.
Yeah, congrats to them. I think this is big news for
Congratulations to
Europe.
the Cusp AI team. And also congratulations to our former colleague Marzi Fadae, also from Amsterdam, graduate of University of Amsterdam PhD program, who just recently got promoted to lead Cohere's AI research lab, Cohere Labs. So she's succeeding Sarah Hooker, who announced that she would quit the role a few months ago. So congrats to Marzi.
Right, and this is kind of in the context of more changes in Cohere.
Yeah, so Cohere raised a very big round, also $500 million US round, and that led to multiple changes in the management structure. Among others, also Joël Pinot, formerly leading Meta or Facebook AI research, was appointed to the leadership team at Cohere. And we see that actually Cohere is also kind of pivoting into enterprise RAG. So they, of course, had a very strong embedding models, but I think their sort of flagship frontier model has not been doing that well. So as a kind of foundational model player, I think they haven't had their best days, and you certainly don't see them in the leaderboards, right, Dinos?
Yeah, I think they're still pretty competitive, but in the terms of in the context of other open source models, not leading the front.
Yeah. So what I find interesting, though, is that they that of course they are pivoting more into enterprise RAG with their North platform being general availability in going into general availability in August. But what I find a bit strange in this play, both from Cohere and from Mistral, is that, of course, if a company chooses their enterprise RAG platform, they are tied to their foundational models for the generative part. So I think the more common strategy in enterprise is to be kind of model agnostic, like we are with Zeta Alpha, and to be able to supply either an open source model for local deployment or any of the sort of leaderboard winners in the generative side, because especially if you kind of move to more agentic approaches to search, then having very strong models for reasoning are very important.
And how do you see search exactly playing into this?
Well, I think strong enterprise search capabilities are not an afterthought. So it's not like you have your leading generative models and then you just kind of tack on some search capabilities, a bit of vector search and a bit of this and that as an afterthought. So in my view, enterprise search, like a solid IT and data engineering foundation for enterprise search is really the key to delivering AI systems that users trust for a whole number of reasons. And we can't go into all of them here today. We will dive in a little bit deeper. But for those people who are interested, I can highly recommend this recent blog post by Ben Lorica on his Gradient Flow podcast and blog, which is called A Pragmatic Guide to Enterprise Search That Works. So basically, a couple of reasons that he outlines is that basically enterprise search is a service, not just a software product. So to tweak all of it is never going to be a turnkey solution out of the box. It always requires very deep customization.
Right, so before we move to the next section, I see here in the chat, they're saying there's a bit of echo. Can you check maybe on Restream if the right mic is on?
Yeah, I think we have that. Let me see if we have muted then. Is it better now?
Okay, I'll keep an eye on the chat. Let us know if there's still echo. So yeah, so topic of the episode is enterprise RAG. But really, why is this such an important topic? What makes it so challenging, let's say? And maybe let's start with the first thing you notice when you get your foot in the door. Enterprise RAG really has a lot of documents and a lot of heterogeneity in the format of these documents. Yeah, so let's say the normal case would be you have a document that has kind of a standard layout. This is pretty easy, and by now you can parse it rather easy and to have it in a normal format with these hyperlinks with some formatting like highlighting and bold text. But where it really gets tricky is when you start adding things like multiple columns. So if your OCR or whatever parser you're using, if you have these sections where one word might be next to another from a different column, and then you read that as one passage, then you can imagine what will happen when you try to use this piece of information to generate answers, right? This is never going to work. And yeah, there have been some examples where models are trained on these wrongly read PDFs, and then they hallucinate and generate information that doesn't make sense. Um, but where it really gets difficult and tricky is when you start adding these more complex but fairly frequent types like graphs, schematics, tables. There you really need to pay attention to how your data looks like and what do you do with it? Do you just still transcribe them, or what do you do with figures that don't have captions? Do you just have tables parsed as the text they're in, or do you want to extract some of the structure that's like in a markdown table or some other meta information about what's in the documents? But that's only like half of the story, right? Because obviously in an organization you want to have just PDFs. You will have your intranet, you will have your websites, blogs, your SharePoint sites that have documents, that have pictures, that have hyperlinks. So you still need to manage all of those, I guess. Um, but if we really want to stretch it with something that's fairly normal as well in enterprise, you'll have spreadsheets, you'll have other tabular data, maybe even SQL databases that you somehow have to figure out how are you going to represent it as something you can search. Do you just, again, take the text? Do you have it as a um, information about what's like the averages of each column? There's a lot of decisions to make this really useful to answer questions.
And we're not even talking about things like the mess that companies have in terms of duplicates of documents, near duplicates, completely outdated information, information that is in decades old scans and all kinds of archives that nobody really knows where they came from and whether something valuable is still in them.
Yeah, and I think like the epitome of all these messiness in the data is something that everyone uses, which is presentations and PowerPoints, which are very
Yeah,
dense in
PowerPoints
information.
are the key store of institutional knowledge, right? And they're like copied and reused all the time.
Right. So let's say there is implicit information that's not written anywhere, but you obviously want to have answers for. So in this fake plot, maybe you want to ask questions about this data point right here. So what was the performance of some category in some year? You'll never find the answer unless you have some way where you can extract information from just pictures. And also in PowerPoints, you often have information that links to previous slides. So it's not just that you can take one slide and caption it, and then you have all the information you need. So definitely a lot of work to get
Well,
this information
fortunately,
out.
we have multimodal models or very strong vision language models. But I think my sort of key takeaway from all of this is there's no silver bullet. It's not like a single very strong AI model that you can just pump all of this messiness through and then it will become neat. You actually need to do the work. When you go into building a rack system for the enterprise, if you really want to move past prototypes, you need to fundamentally deal with understanding your data and building dedicated customized pipelines for all of these different cases.
Right. And usually what happens is you don't have everything in one place, right?
It's spread all over dozens of different applications.
Yeah, so it's what we call information silos. So you, depending on the company, you might have stuff in your drives like Google Drive, OneDrive, and maybe you use multiple. Maybe you have code in your Git repository. You have your instant messaging. You have your CRMs, all kinds of stuff. But in practice, the user of this AI enterprise AI system doesn't care where the information is. You really care about providing one experience where you have your search bar, your chat page, your anything, and it can pull the information from wherever it is and use it in a productive manner
So
to answer the
Dinos,
question.
isn't MCP the solution to this?
Well, MCP handles some stuff, and I think it's definitely making it easier for language models to pull information. But yeah, for example, security is still not at the forefront of MCP, so still definitely not the perfect solution for enterprise settings. It's definitely nice for experimenting and seeing if you can make it work, but it's not the final hurdle, I would say.
Yeah, so what I find interesting about MCP is that it kind of assumes that every user is searching their own data. So there's some sort of first steps in MCP in being able to like impersonate you and make your own data that you have access to available to you. But then it's not really an enterprise solution, right? In the sense that the company is managing all of this data indexing in a central place.
And it's definitely still very technical. So you have to often use API keys and configure it locally. It's definitely not the ease of just logging in and somehow being identified as the user you are and having access to the things you should have, which exactly is the next topic, actually. So you don't, in an enterprise system, you don't really want to be logging in on every website yourself. What usually happens is you have your single sign-on that's managed by the company, and then you log into that, and then you have access to the sites you want to have access. You should have access to and have the resources you're allowed to see. So, in a very simple example, on a presentation, you choose who has access to the presentation, and that's kind of linked to the workspace account. And by extension, when you ask a question, let's say I want to ask, do I get a raise this year? I don't want to see my manager's private documents and notes and get an answer based on information I shouldn't have access to. I think that's
Well,
fair to.
maybe you do want that, but
My
but
manager
your
wouldn't want
manager
it.
doesn't want it.
Yeah, and something that ties exactly on top of that is that information retrieval on an academic point of view is just a dump of documents, but in practice, this is not the case, right?
Access rights, new versions, the information is changing all the time. So you need to sync it very timely. You need to be like almost real time in your indexing.
Exactly. So if someone chases a file, I don't want to see the file that was originally indexed. I want to see what is in my Google Drive right now. So fresh data freshness and timely updates are very important. And yeah, this is a very interesting topic, which we should probably spend some time on. Contrary to popular belief, RAG, an enterprise RAG, is really not just vector search. Many
Far from
people,
it.
yeah, many people, maybe a few years back, you would not even think of using an embedding model, but now most people seem to be thinking RAG means an embedding model in the loop. But yeah, in a more realistic or a bit more advanced setup, you would have steps before you even hit the retrieval engine, such as some intent classification or query rewriting to fetch some facets and use that information, or configure some filtering based on what the user is asking. Then you would probably even fire the same query to multiple engines like a BM25 keyword search and an embedding search.
Yeah, so this
Then
kind of hybrid setup is pretty much the norm these days, right? Because if you are looking for somebody, for documents about a particular product name or product number, you really don't want to use vector search. Then again, if you have a kind of broad semantically um, expanding question, vector search is a great way to find synonyms or related terms, right?
yeah, so the user will never get the question exactly as it's phrased in the document. So that's where embeddings actually are useful for. But you always need to have in mind that the more methods you can combine, and if your fusion method is effective, so a common one that is pretty popular and performant is reciprocal round fusion, where it just basically takes the lists and combines them in one. This is going to give you most of the time the best effect because yeah, more signal is usually leading to more relevant results. And then you can obviously have all the cherries on top, like a re-ranker to just iron out any outliers and only feed relevant documents to the final language model that will produce the answer. So yeah, so in this webinar, we also have, we usually cover research papers. And while this is a very theoretical one by our friends at Google DeepMind and Johns Hopkins University, what they claim on the paper called On the Theoretical Limitations of Embedding-Based Retrieval is that purely by how the embedding space is built, embedding models just can't retrieve information in all of the cases. So they prove this by a very simple setup. So they construct a data set which they call limit. And the documents here are just simple sentences we can see here on the right saying that a person likes some entities. So we have a bunch of these documents, which are kind of atomic on the person level. And then the queries that you issue are specifically designed so that it's asking who likes these entities. And they have constructed the dataset in a way that should be very simple. These entities, each entity is liked by two people exactly in the dataset. And they show pretty surprisingly that even state-of-the-art retrievers, so this is a Google DeepMind paper, so they used their state-of-the-art retriever and also a lot of open source models, none of the embedding-based models, single vector models, could get it, even when you give them 100 chances to get. So the top 100 results, they still don't get both of these two people right.
Yeah.
So this is really
So
interesting.
it's kind of showing deficiencies on the recall side, but this has been well known already for a long time, right? Like BM25 has always been a very strong baseline for benchmarks like Beer and other things. I think sort of these multi-vector models like Colbert have kind of gotten closer, but I think this speaks to the previous slide that you showed, that really a hybrid solution with a strong re-ranker on top is probably what you need, depending on the query intent, of course.
Exactly. Yeah. So yeah, let's move on to a different topic, which is also pretty important to start considering when you start deploying these use cases, which is the scale, right?
Well, if you do naive vector search, it becomes expensive very quickly. If you move into the kind of large, numbers of documents, like 100 million or 1 billion documents, and it sounds like a very large number, but if you remember that every document in a vector search is actually a smaller chunk, then you get to these numbers more quickly than you might think. And what you see in this table is the amount of RAM that you need to actually store all these vectors to make them searchable, because in HNSW and these other approximate nearest neighbor searches, you actually have all of those in RAM. So you see that with a billion vectors, you would be spending about $22,000 per month just on the hardware to store this information. So that's not feasible. So a lot of tricks are needed.
Yeah, so we don't have the time to go in depth in this, but luckily for you, we have a talk from last year's OpenSearchCon. So you can scan this QR code or look up this title on YouTube, and you can find this presentation from Fernando on how to search 1 billion vectors without losing your wallet. I think it's a pretty accurate title. So yeah, let's slowly move to agentic AI, agentic RAG. So really, when we deploy agents and these generative AI in production systems, we don't really talk about this one simple flow where you retrieve documents, template them, and that's it. Usually much more complex these days, right?
Yeah, already this hybrid setup is kind of a multi-part system, right? It's not yet truly agentic because it has like a straight-through flow. But for more complex search tasks, you really need this kind of reasoning and planning. And modern AI search systems, like for example, deep research on your private data, really needs this this more agentic approach, where you are breaking down the task into multiple components and executing in the background many different searches, maybe through a vector search, maybe through keyword, maybe through other external federated search tools that are kind of retrieving, many different aspects of the information, and then synthesizing them and summarizing them in multiple steps.
Yeah, so here you see kind of a common architecture where you have the planner, you have tools, and you have these central components like search and memory, so the agents can communicate and have some kind of state. So yeah, kind of a practical example, like you mentioned, is deep research.
Yeah, so I already mentioned it. So typically for search in complex sort of R&D domains, like chemistry, for example, is one domain that we're working on a lot. If a researcher has this kind of question about improving structural properties of some, in this case, bio-based plastics, if you give them this short RAG answer, they're like, it's kind of correct, but I already knew all of this. And deep research is kind of really what is needed to give them the complete picture, but also to really uncover facets of the research that they didn't know. And this is an example of such an agentic system. So this is the deep research system that we have developed at Zeta Alpha, where the initial query is kind of broken down into many different aspects, and then an evaluating agent, LLM as a judge, evaluates which documents are actually relevant. So kind of in the spirit of a re-ranking, but then more LLM based, generates a first version of the of the research summary, criticizes it again on being complete, and iterates through multiple series of this loop until it either converges or you run out of budget.
Yeah, so deep research is definitely a very hot topic. So I just wanted to shout out two papers in this space, which I really enjoyed. One comes from Salesforce Research, and they actually just have a new reinforcement learning recipe to replicate the original behavior that OpenAI published with their first deep research system. So the system is a single agent. So they're betting against multi-agent systems by instead teaching through reinforcement learning how to do this kind of navigation of information. So they focus on just having simple tools like web search, web browsing, and the Python sandbox. And yeah, I mean, the results speak for themselves. So they just applied this method on GPT OSS 20 billion. And if you see at the numbers, they are very competitive on the Humanity Last Exam and other classic deep research benchmarks like Frames and Agentic Search Gaia, which are competitive with O3. So I think this just shows the power of reinforcement learning with a proper reward signal and the power of synthetic data, since this was training specifically on synthetic trajectories.
Yeah, so of course the downside of using reinforcement learning for training agents is that you do need access to the model weights. So you can only do this with open weights models, or the weights that are developed in your own lab. And it requires a large amount of compute to do this.
All right, so still on the topic of deep research, this other benchmark that came out recently is called BrowseComp-Plus. And yeah, what they wanted to achieve here is usually deep research is evaluated on an open corpus, but instead they wanted to really separate the contribution of search and then the performance of the agentic system on top. So they have this closed collection of documents and the evidence that answers questions, and some challenging documents that often are used as red herring. And yeah, what they show here primarily is on this figure that search is the driving factor and it is tightly correlated with performance. And as a side effect, they find that just giving these language models better retrievers makes them more efficient in how they perform the deep research. So on the x-axis, you see that the same model with a better retriever can achieve the better performance in fewer search iterations. So I think this is definitely a good resource, and hopefully we start seeing these deep research systems evaluated on the same benchmark and not everyone saying we have the best one. Right. So I think a big foundation for enterprise use cases is knowing that the answers you get from a system are correct. And yeah, what is the main system that we use to achieve this?
And that's true for both sort of simple question answering and, of course, deep research, right? Even more so. If you get a deep research report and you wouldn't have sort of the full citation list at the end, it would be pretty useless.
Yeah, I would argue that since you get these language models to do the job for you, your job now shifts to making sure that it is using the right information to arrive at the result. And as we know, verifying something is easier than proving it. So it should be easy to make things easy for the user to check where the information was pulled from and if it's correct. Yeah, so OpenAI actually had a very interesting paper on the topic of hallucinations, and they actually claim that it's not really uh, just because the models are fed wrong information, but it's more foundational. It's based on how they are trained and the benchmarks that we use to evaluate them. So yeah, what do you see here?
Yeah, so in this paper, Why Language Models Hallucinate, they argue that actually one of the main reasons that language models hallucinate is because they are trained the wrong way, right? That they are basically kind of forced into guessing because of the way they are trained using in the post training, the reinforcement learning is done.
Yeah, so as you can see in the figure that on the top right, which was from the GPT-4 release, a model that has only been pre-trained on the web data, it can confidently estimate how certain it is about the answer. But then when they apply this reinforcement learning, this flattens it completely, and then the model is never uncertain. It either thinks something is true or it doesn't. And this is a byproduct of the benchmarks. So to get a better score at the benchmark, you have to get the right answer. If you just say I don't know, most of these benchmarks, as you can see here, they have binary grading, meaning that an I don't know is a missed opportunity to have gotten the right answer, and thus you score lower.
So some thoughts that I have on this paper. This is, of course, a paper from OpenAI, right? And it was wildly popular on social media because it kind of suggests that there's also a way to fix this problem by changing the post training, right? By actually allowing I don't know as a valid answer and grading that in the right way. But my thought on this is twofold. One is, if this is a paper from OpenAI and they've kind of figured this out, why don't they actually do it in training their own models, right? So what could be a reason for that?
Well, yeah, maybe you have to wait for GPT-6, or maybe there really isn't a simple solution and it's just more systematic. We have to change a lot of things. And
GPT-6 will be saying I don't know all the time. Well, that will be very useful. Well, the other thing that kind of also suggests is that in fact a lot of these benchmarks are kind of used in the post training, right? So the argument that this kind of scoring on these benchmarks pollutes the post training actually is an admissal of polluting your post training with data from these benchmarks to score better.
yeah, I mean, definitely everyone wants to be in distribution to perform the best. And so if you start expanding the pre-training corpus with samples of benchmarks, you're definitely getting in a very bad
He
spiral.
who is without sin throweth the first stone, to just add a biblical connotation to it. All right.
Yeah,
So,
so as we're wrapping up, what do you think is next for Enterprise RAG? What's the next big thing, let's say?
well, I think definitely sort of agentic search systems are already the norm, right? Like the simple RAG is just a prototype. You need these kind of more sophisticated guardrails and pre-processing and post-processing steps and iterative reasoning to get really good search results, especially in the deep research domain. We're seeing also that it's becoming acceptable that search systems just take longer to complete their answer. So those are the basic, optimizations that have always been at the forefront of search that require like millisecond response time. Yeah, it seems that people are willing to accept seconds or even minutes of search time if they get high quality results that really save them work. So agentic search is definitely becoming the norm. But then the question is reinforcement learning the right way to optimize these systems, or is it a different approach? And one thing that we are very excited about and working on is this idea: if you don't have access to the model weights and don't have the capabilities to do a reinforcement learning because you don't have the data or compute, there is this new class of agent optimization work where really the LLM itself is the operator to produce new versions of your system. So basically, coming out of earlier work on prompt optimization using LLMs, we see these steps on being able to automatically optimize agents. So here you see an example of that, where you have a multi-agent system. It produces some kind of answer to a particular query, and then you're using an LLM to kind of produce feedback, critiquing that particular answer, and then using that critique to actually rewrite the prompt for some parts of the original agent. And then, of course, you can test this new candidate, this new iteration on your benchmark data, on your validation set or training set, and then eventually use kind of ideas from evolutionary computing to come up with much better candidates for the multi-agent system.
Right, I think this is very exciting, and we already see research work being published on this. One of them, which has gotten quite popular, and this I think is on an upward trajectory still, is GEPA.
Yeah, so GEPA stands for Genetic Pareto Optimizer, and it's actually an example of the schema I discussed in the previous slide. So this is indeed a paper from a bunch of authors at Berkeley and Stanford and Databricks and MIT, kind of the group around DSPy and related work, which is extending the work on prompt optimization into this multi-agent approach, indeed with a sort of evolutionary computing, genetic programming approach, where new iterations are created and then tested on small batches, and then the performance on these small batches determines inclusion in the sort of gene pool for the solution space, and then these solutions are recombined. And what they show in this paper is that indeed this approach leads to much faster quality improvements than reinforcement learning. Here the orange line is GRPO, a popular reinforcement learning applied to the QN model. And we see that the blue and green lines are just going up much faster and actually much higher as well.
Right, and I would like to add on this. So I found this paper which came this week, which is called Maestro, and they focus on joint graph and configuration optimization for agents. So I see quite incremental work on top of GEPA, because as far as I know, GEPA only changes what they call here in this paper configuration, or the prompts of the models. But Maestro takes it a step further to actually change the structure, claiming that the structure is what gives the agentic system new capabilities. And so if you can dynamically, based on this natural language textual feedback from a language model, insert new nodes, where a node can be something like a new step or a new tool or a whole new language model, then you can alternate between these with a fixed budget, alternate between expanding the graph or tweaking the graph, and then going back to optimizing the prompts and keeping the architecture frozen. And yeah, I think the results are also very strong, starting with an initial prompt on 2 datasets on hotpotk for question answering and ifbench for instruction following capabilities. They show first the expected gains with MIPRO and GEPA, and then by using this extra compute to adjust the graph as well, they actually managed to outperform GEPA. And I have these examples here on these 2 benchmarks showing the nodes that they actually added, and they seem to make sense. So If you just have a very naive system, then you can let an algorithm run and get a more complex architecture, which I think is very powerful because you also avoid the going down rabbit holes yourself. Yeah, so I would say this wraps up our coverage for enterprise AI and enterprise RAG. But what's next? Where can you find us next?
Yeah, so I'm really excited about this work on agent optimization, and next week we are presenting some of our own work in this area at the AI conference in San Francisco, in a talk called Customizing Deep Research, ELO Evals, and Optimization of Advanced AI Agents. So I think on the one hand, this is a really promising direction to actually optimize agentic search systems in enterprise to lead them to higher accuracy and relevance without needing a lot of supervised training data. And it's also kind of on the bigger scale of things, a very exciting path on the development of very strong AI systems in general.
Right, so this was it. Thank you for staying with us through this long episode, everyone. And yeah, you can scan this QR code to find our next events. Check out Z Alpha on our website. And as always, enjoy discovery.
Stay tuned.